I'm actually going to be doing part of the presentation that's coming up on this one for the Barnard repair. Rick Johnson is with ODOT. He's the bridge crew supervisor. He actually supervises 2 crews. And I had the privilege of working with him for quite some time back in my former career before I went to, as I was told, the dark side. So while we worked together at ODOT, in 2018 we did this 2019 we did this Barnard Bridge scour repair. In the spring we actually gave a presentation on it. He gave the lion's share of it at the Pacific Northwest Bridge Maintenance Conference, and it actually was voted as the best presentation. So they paid for Rick to come and give this presentation here. It's kind of getting some of that, like, this is at the crew level. This is what some of this work looks like. And this is kind of an extreme example of preservation. Okay, so the Barnard Bridge scour repair. This is a historic bridge, a little outside of the Willamette Valley. And we had a serious scour repair project. It was taken off the last time I was in Boise, which was 2019 for the Western Bridge Engineer Seminar. And it ruined my day. It ruined my conference. But you can see this is just kind of a picture of what it looks like of the footing when it was all said and done. Or well, not when it was done, but when we really got a look at the scour repair. This was a pretty intense timeline. We were notified by the inspectors, hey, we just went to go and inspect this. There was still a bunch of drift piled around this footing. They couldn't get really good access, but they couldn't find any bearing underneath it, so they closed the bridge, which is not particularly common for inspection staff, and certainly not the senior staff that was out there to close a bridge. And so it definitely grabbed all of our attention. We scheduled a follow-up inspection on the 26th where we got the crew out, and we were trying to pull a little bit more drift off so we can get a little better feedback on it. September 5th, we had plans, specs, and estimate together for going out for a bid. Actually, the 5th was when we opened that bid, and I'll dial back to that in a second. September 18th, we had temporary shoring installed. And on the 21st, the contractor had dewatered the entire area. They'd actually diverted the river. And on the 1st, we reopened it to traffic. So in about a 6-week period, we had a failed bid where we actually put together plan, specs, and estimate. We had a failed bid. We had the bridge crew partner with a contractor. We diverted a river, conducted a scour repair, and reopened it. So it was just a really cool example of what can happen when everybody's heading in the right direction, right? No one was trying to get in the way of this project. It was identified as a definite need. So this is the culprit of what caused it. Got this huge drift pile up on this pier. You can see that there's actually a truss behind this span. That's where the channel was supposed to be, but it actually migrated a long time ago and goes underneath this concrete approach span. Notice how high that water is and the drift, how high it's piled up there. You'll see some photos in that kind of the first photo I showed there of how far away that is from the footing. So we did the supplemental inspection very carefully, started pulling some additional drift, had the divers in the water, limiting access to the bridge, right? Our initial reports are that there's not really much holding this thing up. And so as you get someone out there to go and start pulling it away, it's a very high risk situation as we're trying to still get our arms wrapped around of what's going on. I actually had a bet with the inspectors that there's something under that footing. I said, it's gotta be something. I got a couple slides I'll show of why I was able to make that statement, but I said, you gotta find something. They came back with this. So this is a little hand sketch here off to the right. The shaded areas are what we think was bearing still underneath the footing after we did the supplemental inspection. So you got that vertical dimension on one corner of 1 foot. You got a dimension going along the backside with a question mark. I'm gonna guess it was another foot. And then you had 2 feet on one corner and then maybe a couple feet on the other. I mean, so basically we were saying, okay, we found a little something under there, but not much. We also had observed some signs of movement in the bridge rails. There were some things that weren't lining up anymore quite as they had. No giant signs of distress, right? Like not massive cracks in the columns or that kind of stuff, but there was a lot of things that left us very concerned, right? This bridge is in a very unstable condition. This is the footing that we're talking about. So it's this concrete approach spans. You can see there's only 2 columns, only 2 footings there, so you don't have anything in the way of redundancy. Got an arrow pointed here, there's not even continuity in the span above it. This is a expansion joint, and here's a picture of the roller bearings that they're sitting on. And so, I mean, there's really nothing else. Like, a lot of times you can see something happen on a bridge and you're like, the load finds its way. I mean, on this one, there was really no other way for the load to go somewhere. We felt really proud of ourselves. We put together plans, specs, and estimate. I hopped on a plane, I came to Boise, One day into our conference here for that Western Bridge Engineer Seminar, and we get the call, nobody bid it, right? And so we had a pre-bid meeting, we had contractors on site, we got all their feedback, they all seemed excited for it. Nobody wanted to touch it, right? This is September 5th, right? And so we're coming up to the end of summer, the end of our in-water work period, right? We knew this had to happen quick. There wasn't a lot of time for notifications, right? So it was short notice. So we started calling around and asking the contractors who were at that pre-bid of, why don't you want it, right? You weren't even able to throw out a crazy number at it. It was just a nope. For most of them, it was, we're busy. We just don't have any time to do something like this. For some of them, it was the timeline. They're like, this is really intense. Like, we don't think we can do it. And then we found one contractor that said, we actually would love to do this project. We do all kinds of stream restorations. We could divert this river. We could get everything kind of all this containment and stuff together. No problem. They go, we don't want to touch the bridge and do any kind of shoring. They're like, we are not structural folks. And so that just was their hard stop. And so as I was on the phone with them, and I think I was on the phone with Rick's boss. I don't think he was on that phone call. I said, I got it. I said, I'm a structural engineer and I got a bridge crew. They'll go out there and do all the structural work. They'll partner with you. They'll install all the shoring before you get on site ready to do the stream diversion, right? Which was a really short timeline. And then we got off the phone call and I think his boss said, can you guys actually do that? And I said, I don't really know. I said, I better call Rick. And so I'll show a couple examples of just what this shoring looked like, but it was really this partnership of, had a crew that had a lot of technical skill sets. They went and installed the shoring so that the contractor could safely go and do that footing mitigation. My role in the project was fairly minor. I just did the shoring design for it. I drew it on paper and then assumed that they could build it. And I think this is going to be a good presentation on just how challenging it is to actually build some of the stuff we draw. So the design here is a strong back. We go put big steel beams up on the bridge deck and span across those two spans, right? And then go and grab it from above. So you actually get your bearings on the other side of it. You core down through the deck, get a saddle beam down below that cap, and then you hold it up from the top. So you're actually shoring it from above. It's just the one column that we're worried about, so that's kind of a section on it. Here's what the shoring looks like when it was all said and done. You can see the scour repairs taking place in the middle of it. So those beams are continuous all the way across, and you're actually holding it up as the work's taking place. Part of the challenge with this is like you're erecting some pretty big steel beams on the bridge deck. And I also said, hey, this thing's really unstable. You can't put any loads on it, right? Or definitely want to minimize the loads on it as we're doing the work. And so the crews had to kind of work with it. How do you get these beams into place? Yeah, and so that's where I'm showing where the two different footings are on it, and then we're holding it up from above. This temp shoring timeline was aggressive. So the beams arrived on the 10th. The design arrived on the 12th. The crew had them spliced together on the 15th and set upright. On the 17th, they got these saddle beams in place. On the 18th, the shoring was all said and done. That's when I showed back up to the project site. And on the 28th, they were removed because the scour repair was complete and the contractor was demobilizing. So from there, I'm gonna hand it over to Rick and he'll show you how they actually made this work.
Travis kind of touched on that, but there was when I had the meeting with my boss after he'd talked to him, I'd never done any above deck shoring like this before, and I started asking questions. Well, the first thing he said was, we don't know. We don't know that anyone's ever done this to this proportion, or, no one that I could find had any input. So we just kind of went out there and tried to get it together. The first obstacle we kind of came to was everything was heavy. We couldn't lift it with our cranes, so we had to get another crane in there that was bigger. Before the dive team could go in and actually assess what was still underneath the footing, we had to get, so the drifts that we'd turned in high water had washed under the bridge and piled up on the lower side of the bridge, so we had to remove that in case the dive team got washed out. They wouldn't get washed out into a log jam. They could get to shore. So we had to do all that without getting on the deck. I mean, to me it looked fine, but Travis assured me that it was very near catastrophic failure, I think what he said. So we got all our beams out there. They were 90 feet long, 36-inch beams, and in order to splice all these together, we had mag drills, and we drilled approximately like 350 holes with tension control bolts holding the plates on. doing that, we had to have the scaffolding put in, so we had scaffolding contractor putting scaffolding up while we're trying to do these beams and coordinate all this on this small deck that you can't put weight on. So the crews got really familiar with mag drills on this one. There's some pictures of how that went. We spent a lot of time out there from the time I was told that I was going to live out there until it was complete. So I did a lot of sleeping in my pickup, getting up and working, and there's the tension control bolts that we put in the plates to splice them together. So this is these are the saddle beams that we put underneath, which there's some more slides coming up, but it kind of posed a whole different, every step of this was like, we had to figure out how to do it. Just getting these under the bridge, there's no access except for by boat, so we had to kind of come up with a plan to get those into place. A lot of head scratching, trial and error. In my opinion, Travis could probably speak to this too, from the set of plans we got to building this, I think it's probably one of the only projects I've ever done where it looked exactly like it did on the plans. Like everything kind of fell together, and it went really well considering what we had to work with. I'd say this was, you never want to have an emergency repair like this, but I have to say this is one of the funnest projects I've done. So there's what it looked like. Those span 90 feet from cribbing to cribbing, and then braced up. We drove 4x4 bracing in there. And then these are beams on top. You can see the rods going down through. We core drilled holes in the deck for these rods to go down to pick up the saddle beams. There's our threaded rod. So you can see here we got a few of them installed. They're coming from the top and going down through the deck. And then once you get those hung, it was pretty challenging to get the saddle beams lifted up into place. So here's what it looked like underneath. We had our scaffolding down there. We had all the rods down through, and then we had the chore of figuring out how to get those saddle beams under there. So we lifted our boat, put it in the river, and you can see that's bent 2 where they're at, and bent 3 is where the scaffolding is. So we had to figure out how to we put some ropes over bent 2 and so we could kind of pull that beam around once we got it in there, once we got it below. And when we loaded this beam on there, no one had really done this before. You're putting a 900-pound beam on a boat to get it through heavy current. So we kind of made our best guess. And the first time, I wouldn't call it a failure, but we did leave a little bit of aluminum on some rocks down there. Yeah, it was challenging to say the least. So here's our second attempt. We got it balanced out good where we could get in there, and we got it over there to where we think we can get it into place, but we weren't quite sure. We actually used the crane up above and dropped some cables down through those holes where the rods were coming through, and hooked onto that saddle beam to try and pull it into place, but the line was at such an angle that you couldn't just pick it and put it into place. It had to come underneath so it was really challenging. It did work. I'm not exactly sure. It was like something you want to do, have OSHA on site when you're doing, but we did it as safe as we could. So there it is. We got it almost in place now. We're sliding it over. All the really tricky stuff was kind of done at this point. We just had to get it slid across underneath, get the rods in place. So there it is. We've got it hung there. We don't have everything hooked up yet, all the rods hooked up yet, but we have them sitting in place. So we figured that was a win. Like once we got to this point, it was kind of a big load off. So here's a picture of after it was dewatered. The bridge is suspended by the shoring right now. I think we were standing on the bridge when we were trying to develop this whole plan. Travis is standing there, and we kind of just like jokingly said, if we could just divert this river, we could make this easy. And lo and behold, the next day there's plans to divert the river, which we thought there's no way we could do that. But things kind of developed pretty fast. Like it was moving along pretty good. Like I said, I would never have guessed that we could have diverted a river to do our work. So we got all this shoring in place. So I'm asking questions to Travis, like how many times do we have to turn these bolts? How much is it going to pick? How do we do this? What's the deflection going to be? And he kind of just kept that top secret. I'm pretty sure that maybe he was a little bit of guesswork in there too. I don't know.
It's on the slide, 1 3/4 inches.
Yeah, and it worked. I have my doubts. But we put a string line up on the bridge rail actually just kind of as a reference, and it it all came up to where it was supposed to be. So here's an example of like what we had to, where we diverted the river. You can see the round circle there, that's the span where we had the scour. Upstream of that, the oval there, that's where we actually diverted the river over into the other channel, so it went underneath the steel truss portion of the bridge. We filled all these super sacks and just started placing them in the river. They used plastic, and they used a material in the sacks that they could actually, like when they were done, it would be environmentally sound for the salmon spawning and all that. They used a specific aggregate so that they could leave some of it in the river. Then they had all their pumps set up. That's lowering the pump in to dewater it. During all this stuff, they had environmental people there. There seemed like over 100 orange vests down there with environmental, with everybody down there doing the fish salvage and limiting the take on the fish. So there that's the outlet hose. Once they started pumping, they just pumped it downstream. And then this is what it looked like when they started doing the fish salvage. So they had to do the fish salvage from the bridge all the way up to the diversion dam. That's some of them there collecting fish. I'm not sure what kind of fish. I know they ended up with a lot of trout, some eels, and then whatever those are. So this kind of gives an idea. This is the footing. You can see how much debris and stuff is in there, and the challenge of getting enough out so the divers could get in there. We couldn't get the crane on the bridge to lift the drift out because we couldn't get load on the bridge, but it was kind of a catch-22. We had to have the crane in there to get the drift out, but we couldn't get the crane on there to get the drift out because the bridge was failing. So it was kind of a weird dance. I had Travis paint on the deck, like, can we go to here? Can we put our outriggers out here? So he finally put a paint mark and said, don't go past that point. So it all worked out, but it was not easy. So there's the footing when it's dewatered and they're getting ready to go in and form it up. And you can see that there's not much of that footing that's bearing. That's a good picture of it there. You can see there's not a lot there. So that also is a very good picture showing how little, I guess you'd say, is bearing. So they came in and built their forms, just built a bigger spread footing around that. And once it was dewatered, we didn't have a whole, they did a really good job of diverting the river where there wasn't very much water coming into it. I want to say we did the shoring was 4 days, or less than 4 days.
Yeah, that sounds about right. It wasn't very long.
I didn't deal with the environmental portion of it very much, but there was a lot involved with getting equipment into the stream bed, what kind of material had to be placed. We wanted to see a lot more riprap around the footings, and there was just a long process of figuring out what we could put back, what we could armor it with, and where they wanted to see the stream bed as a finished product. So as you can see, it's pretty extensive. That's where that hole was, is now pretty much filled in with material. A lot of the rock they wanted locally sourced, so trying to find all that was, like I said, that wasn't particularly my job, but I was involved with it a little bit on where they could find some of the materials. So when we're done, this is when we took our shoring down, and we're just we're filling in our cores and getting ready to get off the bridge. This was before, when the dive team actually found this, and the bridge inspectors found this problem. It's a high log truck traffic area for however long. The drift problem was probably 3 or 4 months before we found just how extensive the damage was. So this had log truck traffic over it for at least 3 or 4 months, with who knows how much bearing it was on that footing. So there's a picture of the diversion dam. Like these beams, I can't remember what the weight. Do you remember what the weight was on the beams? I would say they were 36 by 225 or something like that. So just moving these into place, we got them all bolted together, and moving them into place was and getting them. They had to be like, just real precision. It was challenging. I had my doubts whether they would even hold together, lifting them over into place. The getting them out into place so that we could bolt them together without being able to get a crane out there, we kind of figured that we're going to have the weight of those beams on the bridge. There's no getting around that, so we just kind of went primitive and found like some round fence posts, put under there and rolled them out onto the bridge. Kind of got them in place and bolted them together there. So you can kind of see how much far it was, like deck to stream, and deck to stream bed was quite a bit of material. We did our portion without 155,000 just for our bridge crew. And so you can see the engineering cost was actually pretty low on that. It's pretty nice.
And having time.
But the total cost was 1.4 million, which for a year after that showed on my budget, it showed me a deficit of 1.4 million, which was kind of, that was kind of nerve-wracking too, but it did eventually come off there. We got funded for that, so it worked out pretty good. Is there any questions?
I'm just curious, when you diverted the water into the channel where the truss was I'm assuming you did some diving inspection of that afterwards. Like, were there any adverse effects, scour effects, due to all that addition of water under the truss span?
Originally, the channel was underneath the truss, the steel truss portion, so it was footing on bedrock. The portion that scoured was footing on cobble, and I don't think it was ever intended for the channel to go to that side.
Were you guys worried about any other freak storms hitting and overwhelming your stream diversion in the middle of your repair?
Not really at that point, because it was September, so we didn't really have to worry about that. We did have to work with, I talked to Army Corps of Engineers every morning to where they would actually lessen the flow so that we could, that scaffolding that was in there, if they would have went back to the normal flow, the bottom of that scaffolding would have been underwater. So I had to coordinate with them every morning and get them to drop it. They'd ask like how much we needed it dropped, like 8 inches or a foot, and so we just coordinated with Army Corps.
I didn't catch, was this a planned underwater inspection, or was it a?
Yeah, it was
okay.
Routine inspection, yeah.
Okay, I was just wondering if it was like a plan of action in response to the event, because I would assume you had it scour vulnerable.
We thought that there could be some issue, but we had no idea that it was to this extent.
Did you anticipate doing any scour monitoring after the fact, while you were down there and had it dewatered, putting in pop-up sensors or something like that?
Not as far as censoring, but the bridge inspectors did do some channel mapping and stuff, so they can go back later and look and make sure that material is staying where it's supposed to be.
I can't understand how you got your environmental permit so quickly. Could you just explain, like, how did you make that happen?
Sorry, what was that?
Oh, you didn't get them. Okay, I got it.
No, that's actually not accurate. The permitting on this is still all done. What we did is we had some fantastic staff at ODOT that were coordinating with some fantastic staff at ODFW. And what it is you're working along as we're going, saying that you're going to get your permit and you're going to take actions that allow you to get your permits. They come in after the project's already done, right? Because you're right, it doesn't happen that fast, but all along the way, we were still following the rules that we had, the dewatering. It was just, if you declare an emergency, you can do it all in 6 weeks.
And that was the key, that it was declared emergency, and the environmental staffing was on site pretty much the whole time.
That's awesome.
Everyone, hand for Rick.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.